Oh, hey everyone, and welcome to this tutorial on how to build beautiful box plots to help you to interpret the data that you have available and arrive at some conclusions. So we're going to learn how to load up the data, work with the box plots, customize it, and then again draw conclusions out of it. So what I'm going to do for this tutorial, I'm going to work through an exercise that I normally do in class using other Excel macros. So today I'm going to work through this exercise with RStudio. So this is the problem that we have here. If you've ever been in one of my classes, you may come across it. We have a F1 racing team here dilemma. Take, for example, that you are the director of a well-known F1 race team. You're actually currently looking for a new racer for the next season and one who's willing to be trained and mentor for the next decade. So this is the table here with some average speed in kilometers per hour or 4 racers for the same type of track for the past 20 weeks. So these are your candidates. So use some concepts and tools that we're going to learn with RStudio. Which racer would you hire and why? How can you prove that your decision is based on sound statistical analysis? So that's kind of the problem that we were going to work with. I'm going to switch back to our RStudio and I'm going to start from the very scratch. So the first thing that we want to do is to make sure that you are in the correct directory where your files reside, where your script and your database files are actually sitting in. So I have mine already selected here, and I want to make sure that I go to more and then I set as a working directory. So when I do this, every single thing that I do from now on within the RStudio environment, it's going to draw files from this directory. So it's always important to find your files. It makes things a lot easier. I have a bunch of different files here. I'm going to use a few of them. And then to make sure that everything is going to work properly, you're going to draw the files from the right place. You set as a working directory. So the very first thing that I'm going to do, I'm going to pull up the script that I have already written in R. And then we're going to walk through that. So here's my script. F1 Boxplots script R. By simply clicking on it, I have a new piece of the window here that brought up my script. At the bottom here, I still see my console, so where I can run some tests and see the outputs of my script. Recall that on the right top section here is my workspace environment. As I work through this, you'll see some things coming up there. And then on this side here, on the bottom right side, I have files, the plots that I'm going to generate if I need any help, and the package that I have installed. So I'm going to stick basically with this tab here, files and plots. So there's a lot of code in here, and to save time, I've already written, as I said, I'm going to walk you through it. And then we're going to build this together and interpret, customize the box plots, and go back to that question from the problem and try to answer it. As a reminder, whenever I'm using hashtag, it means that the code is not going to be evaluated, the code is not going to be run. So it's just a comment that I'm adding. So I kind of explaining what I'm doing here. So step number 1, importing the file. Now I have some coding in here, and I'm actually going to run it line by line. So the first thing that we do is to upload this library, read Excel. You can hit run or control enter. Then I'm going to create an object called F1 Boxplot exercise that comes from reading that Excel file. And then I'm just going to view the file, which is going to open a new tab here just for me to check what's going on. So this is one way of doing it. The other way is, and I'm going to close this tab here, and also from a workspace environment, I'm going to delete this file that I brought into RStudio just so I can show you how to do it another way. So instead of running this code here, you can simply go to the file itself, which is my Excel file here, and just click on it. Once you do it, you go to import dataset, and this new window will come up with a preview of the data. And if you notice here at the bottom, that's that code that I just showed you, the 3 lines code. That's exactly what it's doing here. But just with the click of the mouse, you can perform the same task. So I can preview the data, and in this case, I'm just going to click on import, which is the exact same thing I did before by using my lines of code. Sometimes I like doing this because I can just, if I know where the file is, or if I am setting, already working with my directory as my working directory, I can just execute this code quickly, and I don't need to go click on the window, preview the data, so on and so forth. 2 ways of doing the same thing. So as usual, I'm going to check the structure of the file by using the str function. So str parenthesis, the name of the file. If I run that code, we'll see here in my console that I have a table 20 by 4. I have 20 observations and 4 variables. So recall that in RStudio, observations are the rows and the variables are the columns. And that's what it's telling me here. They're all numerical. And if I go to my table, that's exactly what I see. The 20 rows or the 20 observations with the 4 variables, 4 columns. All good to go. Now I have a whole code here to create the Boxplots or the comparative Boxplots for all the 4 racers. I'm going to run it and then I'm going to walk you through it. So I have my full-blown comparative Boxplots done, but again, just so you know what I'm doing here, let's walk you through this code. The first thing that I'm doing here is the function Boxplot. So this is RBase. I'm not using any package here, I'm using RBase. And because the file already came with this structure, I have racer 1 in one column, racer 2 into the second column, racer 3, racer 4. Because it already came this way, I can simply run the entire file that is going to automatically pick up all of those 4 columns. And I will show you in a bit how to do it differently if the file comes in differently. From here on, it's all about customization. So all of this pretty stuff that you see here on the graph comes from more coding. So Boxplot, name of the file, comma. Don't forget the comma. If you don't put this comma here at the end of each line, your code is not going to run. The first thing that I did here was to customize the color of the box. So col for color equals biscuit. It's just one color out of many that RStudio has available. So this light yellow color you see here is that color biscuit. Comma, new line. Outlier color, so that's the color of the outliers, red. You can see here that they are red for where I see the outliers. And then the outlier PCH. PCH is that plot character, that type of character that you show in this case for the outlier. So this little diamond here, the filled diamond, is outPCH number 18. You can search that up. There are lots of different types of PCH available. I have my Boxplots in vertical orientation. That's why it says horizontal false. And if I change this to true, just to show you what's going to happen here, it's going to change the orientation of my Boxplots. It works the same way, I just don't think the visual is as good as the other one. So I'm going to go horizontal, false. And this is the width and the sizing of the box itself, 0.3. I'm going to run it again so we can go back to where we were before. Comma at the end of the line. Now I'm giving titles. The main title, within quotes of course, F1 Races Comparative Boxplots. The color of the main is black. You can change that in Customize. CEX, so that's the abbreviation for Character Expansion Ratio. It's the size of the font in this case. So CEX.main 1.5, which means 50% of the regular size. And the type of font, which is in my case here bold, is number 2. So it goes from 1 to 4, regular, italic, bold, and bold italic. Comma at the end of the line. My X label, my X axis label, where you see competitors, which is right here, competitors. And then my Y lab, or my Y label, kilometers per hour. The color for the labels is blue. So all of this portion here is pure customization. You can make your comparative box plots look very pretty by using these small codes and different custom things you can do. So, and that's your box plot. As you can see, you have Racer 1, Racer 2, Racer 3, Racer 4, and we'll talk about these outliers and the full analysis here when we get to the problem resolution answer to that question. Who would you hire if you're looking into these candidates? Now, as I said before, depending on the type of the data that you get in your hands on, we have an alternative to creating these box plots. It's going to create the same thing, but if the data comes into you differently, in a different way, you're just going to have to tweak a couple things and then use the function a different way. So what I'm doing here, I have another file which is exact same data, exact same information from another file in a different format. So I'm going to actually bring up that file as well. So you can see on my workspace environment now I have the boxplot exercise and then the boxplot exercise 2. And notice here that I have 20 observations of 4 variables. So that's my first file here, 20 observations or rows, 4 variables, so 4 columns. And now I have 80 observations of 2 variables. So let's see what that is. We can use the function view to see what this file is all about. So in this case, I have a column with racer and a column with kilometers per hour. So again, it's the exact same data, but it came in a different format. So this is the first one. You can see each race has its own column. And this one is just a one column for racer and then goes 1, 2, 3, 4. And then their respective kilometers per hour. The exact same information, just in a different format. So if that's the case, we still use the boxplot function, we still customize everything the exact same way, and the only thing I changed here was just the color, just to see a different way of doing this, but it's the exact same analysis. But instead of box plotting the entire file, I have to specify in this case that I want to box plot kilometers per hour by, there is a small tilde right in the middle there. So box plot kilometers per hour by racer. And the rest is exact same thing. Again, I just changed the color here to show that this came from a different file. If I run this, I get the exact same plot with this nice light sky blue, but it's the same analysis. As a reminder as well, we can also export this plot. It's a beautiful plot. So you can save as an image, you can save as a PDF, or you can click on copy to clipboard. That's your graph right there, and you can copy the plot to your clipboard and then paste it in a PowerPoint file or anything you want. So same analysis, just a slightly different way of creating these box plots because the data came in a little differently. Okay, so let's go back to that question and let's have a look at this analysis. Let me just move this out of the way here. So, who would you hire and why? Well, let's have a look at the box plots. So this is the one that we created with RStudio. And what I have here is that Racer 1 and Racer 4 show more consistency, less variation. If you look at their box plots, they don't have outliers, the distribution of the data is pretty good. Their mean and median are very close to each other, and the overall box plot is well distributed. Racer 4 shows much more tightness in his racing pattern. So he has a tighter box plot. He is a bit more in control, so to speak, of his speed, of her speed. Less variation, tighter box plot. Racer 2 is perhaps the riskiest, but he also shows the best performance of all, because he's up here. So he is up here and he has a higher medium. His or her box is sitting at a higher level. However, his mean and median are off. His outliers are quite distant from the mean, and you can see the outliers here. And his whiskers show that this distribution is skewed. So he's sitting at a higher level overall, but he has a lot of really bad racing events, so to speak, with really lower kilometers per hour. So I'm not sure. Racer 3, similarly to Racer 2, presents outliers as well. However, it could be that he has great potential, since his outliers are higher and distant from his median. So he's the opposite. He is at a lower level, but more consistent, with the data better distributed than Racer 2, and with a couple of outliers on the higher end, which is, it could indicate he has talent. He can get to that point. He's just not there yet. So at the end of the day, there is no one right answer. The way that I see this is, from a long-term perspective, Racers 1 and 4 show more stability and less variation. Therefore, they're good candidates. Racer 1 more than Racer 4. Racer 2, although the best performer, at least in the short term, seems to take more risk and show more variability in his racing pattern. This may suggest that he may not be able to keep up with his performance. Racer 4 is perhaps the least optional choice. You know, he's probably what they call the good loser, right? He's pretty consistent, but he's not going to go far in terms of competitions here. So this is how you use RStudio to create beautiful comparative box plots. All of this coding, as I said, it's used for the customization. This function box plot is from our base, which again, you don't need any specific package to create this. I hope you've learned something here today, and I hope to see you next time.